This is GPT-2. We covered GPT-1. This is going to be GPT-2. And this is going to be an assignment for you to watch that YouTube video online. I'm going to give you a quick overview. And then in the meantime, you can think of questions to ask. And we had a very good question right now. The question was, can you modify a language model so that it can do translation, for instance? You have sequences of different lengths. Or we can do all of these in a simple fashion. Maybe question answering, machine translation, reading comprehension, summarization. This summarization I forgot to mention. If you search for something these days on Google, you're going to notice that something is different compared to prior to 2018. You're going to see that immediately. There is going to be an answer to your question. Your question could be in natural language form. You could have a question that has a sense that a human is speaking. Prior to 2018, all of these frequent words, such as are, in, of, there, none of them would matter. If you type something in Google with them or without them, Google would just ignore them and then give you an answer. And that was based on keyword search. It would find the keywords in a sentence and then go and search for your intent on the internet in their database. But these days, something is different. We can talk to Google as if it's a human being. We can have fully elaborated sentences the way that a human asks a question. And then something nice happens. The answer to your question pops up. And at the same time, it's going to highlight portion of the text or the document that it extracted the answer from. So it's a more humanly way of interacting with computers. And that's exactly this question answering or even summarization. Things are becoming more and more human-like when you're interacting with the computer or even searching for something on the internet. Okay, now let's move on with GPT-2. It has more parameters. And we learned that whenever the entire internet is in front of you, you have plenty of data, and your model, no matter how large it is not going to overfit. So now you are just limited by the amount of compute power in front of you. The more compute you have, the more infrastructure you have, the larger a model you can train. Okay, so far so good. And that is beyond our capabilities in academia. So we are not going to worry about that too much. But there is a nice idea here. The idea is you want to condition on a task. For instance, you want to say, give me some output. This is your input. And I have this task in front of me. Maybe it's a classification. Maybe it's a translation. One option is like what Bert was doing. Have different heads for different tasks. The body is the same, the body of your neural network. You're just changing the head based on the task. So you have task-specific heads. And that is, you're changing your architecture slightly. There is another way, and that is at the algorithmic level. And we are going to learn about it. And that's the concept of model-agnostic meta-learning. And the idea of meta-learning is you are not going to be good at solving a single task. You're actually not going to be good at solving any task. You're just going to put the parameters of your model in a sweet spot so that depending on the task, you do a few iterations of optimization or gradient step, and then your model adjusts. You don't need to change your architecture. You're just modifying the parameters of your architecture. And this one we're going to learn about when we go to reinforcement learning. There's going to be a chapter that we're going to cover, model-agnostic meta-learning. But when it comes to language, things are beautiful. You can actually specify what you want in human language. You can say, translate to French. You are giving your model a prompt. You're just going to say, translate to French, concatenate it, perhaps with a separator, with the English text, with the French text, and then you do next word prediction or next subword prediction. So everything now is going to turn into language modeling, next word prediction. You can change your prompt to a different prompt. For instance, answer the question You put a separator, a document, the question and the answer within that document. Or you can say, is this a positive or negative review? You can just explain it. There are some technologies here that we need to recall. One of them is BERT was using word piece. GPT-2 is using byte pair encoding. It's actually byte level byte pair encoding. And there is going to be some pre-processing steps. And we learned about sentence piece, and later on sentence piece is going to replace all of these, because sentence piece does that on its own. It's going to do lower casing if you want. It's going to do the pre-processing on its own. And normalize your text. Okay, perfect. You have the option to fine tune here. For instance, if your downstream task is reading comprehension, translation, you might have task-specific data or summarization or even question answering. You have the option to fine tune, but the paper is going to opt not to do so, just to prove a concept that whatever that you learn through pre-training is actually very useful. You can do few-shot learning or not even fine-tune at all, zero-shot learning for your downstream tasks. The performance is not going to be great. It's not going to be a state of the art because you didn't fine-tune at all. You are not going to be the state of the art, but you are proving a very strong concept. And the concept is you're actually learning these tasks through pre-training. And how is this possible? How are you learning to translate without having pairs of English and French data? The answer is on the internet. There is some naturally occurring translations on their own. For instance, this sentence has its translation within a bracket, or you can say which translate as, and it is sometimes better in French, perfume, parfum. So you can have naturally occurring data. The other ones, you can specify what you actually want. If you want to do question answering, you give it a paragraph as an input, you give it a question, you give it an answer. This is part of the prompt. This is one-shot learning. You just showed your algorithm one question and one answer with a single prompt. And then you're going to give your question and it's going to give you the answer. It's going to understand that you're asking some question from the paragraph. So without any fine-tuning, you're going to get some performance. The performance is not bad. It's not the state of the art. But you can definitely make them a state of the art by fine-tuning on these downstream tasks. And that's why GPT-2 is a powerful idea, is a powerful model. Forget about the scale. We always talk about the scale, the number of parameters that these large models have, but there is some brilliant idea behind it, and it's proving some strong concepts here. Any questions about GPT-2? So was everything clear?
So in the second example there for question answering, are you basically feeding in the paragraph plus the first question and answer?
Exactly.
As the document, and then the question would be, where does she live? And then it would, okay.
And it would give you an answer.
Okay.
And all you are doing is next word prediction.
Right.
Most of these words, you're giving it up until this last question mark, and the next word is generated. So it's a generative model.
Okay. Thank you.
And all you're doing is this. Given the past, predict the next word or next subword.
So like, how would that work with summarization though?
It's going to be the same. You mean here you are going to be doing, you have two types of summarization. So I need to clarify that. Sometimes you might say, highlight a portion of the text that summarizes this document or is the most important portion of this text. Same thing for question answering. You can say, highlight the portion of the text that answers my question. Those ones you cannot do with GPT-2, but what you can do with GPT-2, it's a generative model. You can actually summarize the text by generating words afterwards. How would you do it? You're going to say, for instance, you're going to give it the passage, the document. You're going to say, summarize this document, and then you're going to keep generating words one after another. Or you can say, summarize this document, give it the document, and then it's going to keep generating words for you one after another until it sees a end of sentence or some symbol. It's going to keep generating as long as you want. So one cool thing about language model is that it can start talking on its own about some random stuff. You keep generating next words. So does that answer your question? Okay, sounds good. Any other questions about GPT, GPT-2? In that case, we can move on.